So when we have more than one term being a variable or a number, we can call our base a product base, just like here. Okay, so before we had 3 squared or x squared, now we've got 3x squared. So let's go through each of our 3 rules now and see how this kind of idea is going to play into each of our rules. So let's start with the product rule. Let's go, when using the product rule with product bases, multiply the coefficients and add the exponents, just like before with the product rule, right? Some of you guys write really fast. It's good. So when we're using the product rule with product bases, all we got to do is multiply. Guys, let's focus on the lesson, please. Multiply the coefficients, and then we're going to add the exponents just like before. So what does that look like? Let's say we got something like, I forgot what color I do my examples in. Let's do example A with 2a squared times 8a to the 4th. Let's do that. So last week with the product rule, it would have just been 2 squared times, 2 to the 4th. Or it would have been a squared times a to the 4th. Now we've got product bases. Give me a thumbs up if you know what I mean by product bases. Okay, I'll explain it again, that's okay. So a product base is 2 terms as the base, okay? X squared would not be a product base because you only have 1 term in the base. But here we have 2. It's basically just a variable with a coefficient. That's all a product base is. So here, we've got 2a squared and 8a to the 4th. It's okay that our coefficients are different because our variables are the same. So all we're going to do here is we're going to multiply our coefficients. Let's do these 2 colors. So our coefficients are 2 and 8, just the number in front of a variable. And our exponents are 2 and 4. Okay, so we're going to multiply 2 times 8. And then we're going to add our exponents of 2 plus 4. So this is a little bit complicated. I understand if you're confused. We'll take it slow, don't worry. So our new coefficient becomes 2 times 8, which is what? 2 times 8, anyone got that?
16.
16, thank you. Our new coefficient is 16. Our variable stays the same. And our new exponent is what? 6. 2 plus 4 gives us 6. And that's our final answer. 16a to the 6th. So last week, this is how we used the product rule, right? If we had a squared times a to the 4th, that's just a to the 2 plus 4, and that gives us a to the 6th. The only difference with this new kind of addition to the product rule is that we're multiplying our coefficients and throwing them in front. Right? With our example A, we still got a to the 6th, so the product rule as we know it still works the same. We're just adding in these numbers in front and multiplying them together. All right? Let's see. If we had something else like, let's do 10x to the 4th times 3x to the negative 2. Let's do that. So one way you can even do this, if this step is confusing to you, which just looking at it for me looks confusing, I might recommend just solving this like the normal product rule, just taking a look at your variable, and then just multiply the two numbers at the end and stick it in front. So this would be 10 times 3 out in front times x to the 4 plus negative 2. So our variable has a new exponent of 4 minus 2, which is 2. And then what number do we have as our new coefficient? 30, right? 10 times 3, 30x squared. Quick show of thumbs, up, down, sideways. How are we feeling about this so far? Just so I can get an idea of where everyone's at. Okay, good. Good, I see some thumbs up. I assume those who don't have a thumb up, that means thumbs down. So, hopefully you can see that we're just doing the product rule with these extra numbers in front. And once we get to the actual work and we actually get going with it and doing a couple problems on our own, I'm sure it'll click and we can go from there. So that's how we're going to use the power of a product rule with the product rule. We're not really going to call this the power of a product rule. It doesn't roll off the tongue like the other rules do. So this whole lesson that we're doing today is just basically multiplying, dividing coefficients. That's our big thing. So we took a look at the product rule. Let's look at the quotient rule. Quotient rule. Oops. Can't even see. There you go. So when, I'll just write. All right. So when we're using the quotient rule with product bases, we're going to do things a little bit differently. Like I mentioned in the warm-up, we're going to expand out our numerator and denominator completely because it's going to be a lot easier than doing it the other way. Then, just like we know how to do, we're going to cancel out common terms or factors. Either term is fine. I'm going to say them both, so I put them both because I go back and forth. But you're going to cancel out any common factors that you have on the top and the bottom, and whatever you're left with is your answer. Yes? Yeah, go ahead. So let's take a look at what an example of this is going to look like. Example C. Let's do 12x over 2x to the fifth. Okay, and with the quotient rule last week, we would have just seen this, right? X over x to the fifth. Now we're just adding in coefficients. It's the same thing, though. And let's see what we're going to do. So, while we're starting out, I want everyone to do this. I want everyone to expand out all the factors on the top and on the bottom. So can we break 12 into factors? What two numbers multiply to get 12? Azalea? 4 and 3. Perfect. 3 is a prime number, but what two numbers multiply to get 4? Jordan?
2 and 2.
2 and 2, right? So we can rewrite 12 as 3 times 2 times 2. Okay, a little bit of prime factorization. You guys should have heard that before. And then we've got 1x up in the top as well. Can't forget about that x. Then on the bottom, can we split 2 up anymore? No, 2 is a prime number. And then how many x's do we have on the bottom? Blake, how many do we have? 5, right? Those are 2's. I keep messing up too. All right. So that's what we're working with. Take a look at our numerator and denominator. Is there anything else we can split up? I'll take your silence as a no. That's correct. There's nothing else we can split up. All we have to do now is look for and cancel out common terms and factors. So, it looks like we've got a 3 on the top. Do we have a 3 on the bottom? No, we don't. We got a 2 on the top. Do we have a 2 on the bottom?
Yes.
Yes, so we can cancel out this pair of 2's here. We got another 2 on the top. Can we cancel that out as well? No, we need a 2 at the bottom to be able to cancel. It's got to be a pair, right? And then we got an x. We can cancel out one of these pairs of x's as well. Okay, so we canceled out our common terms. Now all we're left with on the top is 3 times 2. And all we're left with on the bottom is x times x times x times x. Does anyone need help seeing how we got from this big step here to this step? Yes, that's perfect. That's going to be our next step. Does anyone need help figuring out how we got to this point here? Okay. So, we're going to simplify now. We're going to condense everything back down. On the top, we've got 3 times 2. What's that going to give us? 6, right? And we got how many x's do we have on the bottom? Rwana says we've got 4. So we've got x to the 4th. So think of it like this. We've got this confusing question, right? We've got to take it apart, expand it, figure out what we can remove from that expansion, and then put everything back together. Okay? Just to put it into some tangible ideas here. You're given a box that's got some issue with it. Maybe you're an engineer, you got to figure it out. The first step is going to be to take it all apart, right? Piece by piece. Figure out what's going on. When you see, oh, hey, those pieces are broken, let's take those pieces out. Take them out, everything's running smoothly. You can see, hey, there's nothing else that needs to be changed. Let me put that back together, and that's what we want. Okay? I don't know if that analogy helps you. Hopefully it does.
Excuse me?
Yeah.
May I use the restroom?
Yes, go ahead.
Thank you.
All right, let's do one more quotient rule example. If we've got, I don't know, maybe, let's do 4a squared over 16a. I don't know, why not? So our first step is going to be breaking up our numerator and denominator into its prime factors. What two numbers multiply to give us 4? 2 and 2, right? And then we've got 2 a's on the top as well. And then what two numbers multiply to give us 16? 8 and 2, right? What two numbers multiply to get 8? 4 and 2. What two numbers multiply to get 4? 2 and 2, right? So 16 gets broken up into 2 times 2 times 2 times 2 times a. Give me a thumbs up if you're comfortable with expanding out these product bases like we just did. Okay. Just so you guys have a heads up here, I'm going to try and confirm today that I could tutor after school on Wednesdays. So if you need additional help, Wednesday is going to be the day to do it, but I just got to confirm, okay? And I'll let you know.
What about like students helping too? Like, could we help you help?
Oh, that's a good idea. I can look into it. I think that's a good idea. I don't think we've done it before, but what do I know? Maybe they have.
You can try it out.
Yeah, I'll try it out. I'll look into it. We'll see. The thing with that is, though, I got to make sure that you know exactly what you're doing, too. Okay, I'll make a note. All right. So let's go ahead and do what we did before, and that's find common terms on the top and the bottom. We've got a pair of 2's here. We got a pair of 2's here. And a pair of A's right there. Any other pairs we can cancel? No, that looks like it's about it. Boom, 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 boom. Now all we're left with is A on the top and 2 times 2 on the bottom, which gives us A over 4. All right, last thing. Questions on how we break down the quotient rule? Hopefully this makes it a little bit easier, just so you can see all your terms. And then once you get comfortable with the process and you start recognizing patterns, you don't have to do this whole expansion thing. But for today, I want everyone to get in this habit just so we can see exactly what we're doing. Finally, let's talk about the power rule. Last thing here. So when using the power rule, with product bases, just distribute the exponent to each term in the product base. So we talked about the power rule on Thursday, right? And we see x squared raised to the second power. We know to distribute that exponent and multiply them together. Now we're just going to have to make sure we distribute that outside exponent to our coefficient as well. Okay, so our outside 2 is going to get distributed to the 7 and to the 2. And that's what we get for this up to this point. It's not our answer, but that's where we get to. So we distribute that outside 2. The 7 gets an exponent of 2, and the x squared gets an exponent of 2. It already has that 2, so we're going to multiply them, just like our power rule taught us. 7 squared gives us 49. X stays the same, and our new exponent, 2 times 2, is 4. So our final answer here is 49x to the 4th. And then last example, let's say we've got 3b to the negative 2, or 3b to the negative 3 raised to the 3rd. We're going to distribute our outside 3 to both of our terms. Giving us 3 to the 3rd times b to the negative 3 times 3. So we distributed the outside exponent to our coefficient, and to our variable. The coefficient just gets that exponent on top. But with the variable, because it's already going to have an exponent, we have to multiply, right? 3 to the third power, anyone know what that is? Brandon, 3 to the third power? 27, awesome. 27. B stays the same. And then what's negative 3 times positive 3? Negative 9. Is that our final answer? No, what do we have to do, Jordan? We have to make our b to the negative 9 positive. Now this is where it gets interesting because our 27, again, does not get moved down. It doesn't have a negative 9. We already solved that exponent. The b is our term with the negative exponent, right? So 27 is going to stay in the numerator. B to the negative 9 gets flipped to the bottom and made positive. Example F is a little bit harder than I think we're going to need to know, so don't worry too much about that. But essentially it's just a combination of all of our concepts already, right? You have to use the power rule here, you have to evaluate our exponents, and we have to use negative exponent rule. But that's it. That's all we're doing today. I say that as if it wasn't a whole lot. But hopefully you guys can see that we're just sprinkling in a little bit of multiplication and division into the concepts that we already know how to do. So we're building on last week's information. It's kind of not a whole new thing. Yeah?
At the end of the term, are you going to do a notebook check?
No, I'm not going to check your notebooks. If you want me to check it, I absolutely will, just to see how it looks. But I tried to do notebook checks last year, and it was a whole mess. So I said, I'm not doing that again.
Why not?
Because I had to stay here and grade them. Because I couldn't carry 100 notebooks with me to my car, so it was not a good idea.